Hello everyone. Today we will apply a Markov chain equations, for example, those which are for time till absorption, on a real problem taken from the book by Mark Joshi. It's a great book that talks about quant finance interview prep with questions and solutions. And the question is, you toss a bias coin, what is the expected length of time until a head is tossed? In other words, how many times you need to toss the coin until you get a head? And part B for two consecutive heads. What I would suggest to do is the following. We start with part B because part A we will be able to deduce once we get to solution. And also, and most importantly, from the solution we will be able to generalize to the case of 3 or 4 or 5 or n heads. And this is great. This is great because at times these problems involving big numbers, let's say 5 heads, they're intimidating, they look scary, but they shouldn't once we know the approach and can deduce the formula. And when we have a formula, everything becomes simple. So with that, let's get started. So first, let's uh, let's have a Markov chain for our problem. Our problem is we need to get to two consecutive heads. How we do that? Well, we begin at the state S, which is our starting point, starting state. Then, if we are lucky, we get to state H. And then, after S, H, finally, if we are lucky again, we get to state HH. Now, what are the probabilities for this to happen? Well, from S to H, we go with the probability, it's bias coin, so let's call it P. This is our bias, probability to get ahead. From H to double H, we go with the same probability, P, because it's just getting one more head when we already have one. Okay, but what about tails? Well, if we are at the start and we are getting a tail, probability to get a tail is 1 minus p. Why? Because probabilities sum up to 1 and 1 minus p plus p is equal to 1. If we are at h and we get a tail, we are back to start to state s with probability 1 minus p, and it means after that start it all over again. That's it. This is our full Markov chain that describes the whole problem. Now let's define our states. HH is a target state. Once we get there, it's all over. So this is our absorbing state. What about H? Well, you see, once you reach H, you can go to S, and then from S you can go to H, and then back. So we keep circling here. We keep transitioning. So both are both are transient state. Transient and transient. Alright, now we are fully done because we know all the states, and since we know the states, we know which equations to use. Time mu for absorbing state H by definition is 0 because it's absorbing, and intuition is the following. How many more steps you need to get from HH to HH? Well, you're already at HH, so it's 0, just to check. Do we have any other absorbing states? No. So we are done with the first part of the first set of our equations. Let's go to second set of our equations, because what is left is two transient states. Well, first for state mu h. This is the time to reach absorbing state HH if we are to start from state H. So what this equals to? It equals to 1 plus, because it's at least 1. Now 1 plus what? A summation of over all the states that can be reached from I. Our current state I, current state is H. Which state can we reach from H? Either S or double H. So with probability P, we can go to mu HH, or with probability 1 minus P, we can go to mu S. But notice mu HH equals to 0, so this simplifies to 1 plus 1 minus P mu S. Now, what about mu S? It's again 1 plus. Now, where we can go? We can go with probability P to H, or with 1 minus P back to S. So with probability P, we can go to mu H, or with probability 1 minus P, we can go back to mu S. Now, from this equation, I would like to simplify it a little bit, and I would cancel mu S on both sides. So what we will get is the following. We will get 0 equals to 1 plus P times mu H minus P times mu S. From this, I would express what is P times mu H. It's simply, you place it back, P times mu S minus 1. And now we divide by P, and we are done. Mu H is P times mu S minus 1 over P. Now, what can we do? Well, why don't we plug it back over here, because this long line is for mu H. Then what we get is P times mu S minus 1 over P. Now, from this equation, what can we say about mu S? Well, let's start rearranging terms. What we get is the following. We will get P plus P times mu S minus P squared times mu S equals to P times mu S minus 1. Now you can see that we can cancel this term on both sides and finally get to mu S. So what is mu S? Mu sub S equals to, we just put it to left hand side, right hand side. It becomes 1 plus P over P squared. Now, remember I mentioned that we will see the formula. The formula, you can prove it by induction, is the following. The formula is mu from start S of n heads equals to P to the power n, and here we have a summation P to the I, where I goes up to n minus 1. So this is the formula. If we are interested from the start in getting to two heads, what we have is a summation of zeroth power term, which is 1, plus term n minus 1, which is first power term, and it will be 1 plus p over p to the power n, which is two heads, and that would be p squared. If we are interested in getting to three heads, we will have 1 plus p squared over p cubed. Now, when I mentioned that we can deduce the case of the first head going from star to h, well, that would be just 1 n equal to 1, so the probability would be 1 over p. And that's basically it. What we've managed to derive is the following. We started with a Markov chain, and we've got a formula which is generalized to an abstract n of our interest. How we've got there? We first calculated what is mu h from one equation, then mu h from another equation, and since mu h uh, in each equation is the same, we equal both sides to be able to get to mu s. Mu s, again to remind you, is a time till absorption, which means time to get to HH if we start from this state, and this state is mu s. And we found that mu s is equals to 1 plus p over p squared, but the more general formula is the following. If you have n heads, you divide by p to the power n, and you sum up all the terms to the power up to n minus 1. And in case we are interested in getting just one head, the whole formula gives us 1 over p. If we are interested in two heads, it's 1 plus p over p squared. If we are interested in three heads, it's 1 plus p squared over p cubed, and so forth. And this is how you apply Markov chain equations for time till absorption type of problems. And as you can see, it was quite simple. First, you just start with a Markov chain. You put arrows and then for yourself, and then probabilities with which transitions happen. You define which are absorbing and transient states based on a given problem. Then you apply the following equations, whether it's equation for absorbing or transient state, and you get to the solution just doing simple math. This is how we solved one type of a problem, and in the next video we will solve a problem, what is the probability till absorption. Thank you for watching, stay hungry, stay humble, till next time.